Question 8 is one of my favorite questions on the paper. Maybe not everyone's favorite when they look at it and realize it's, there's a lot of context to this question, a lot of words in there. Each year, a number of chief examiners' reports are released once the Leaving Cert has been completed and marked. In 2015, a chief examiner's report was released for Leaving Cert mathematics. Amongst many other things, it explored the participation rate of students at higher level, ordinary level and foundation level, and the various grades received by students in those levels. A maths teacher in West Cork reads the report and decides to do some statistical analysis of his own students. He has a class of 15 students who sat the Leaving Cert higher level maths exam in 2015. He firstly compares their pre-maths results against that of their actual Leaving Cert maths results. He compiles the following table where the results of the pre-exam in the Leaving Cert are given in percentages to the nearest whole number. Okay, so we've had to read quite a lot before we've gotten to anything to do. We see here we got these 15 students. We say student 1 got 40% in the pre, 55% in the Leaving Cert. Student 6 here we say got 60% in the pre, 80% in the Leaving Cert. Who's the highest student? Student 11 got 85 in the pre, 91 in the exam. So it looks, just from even those small few that we looked at there, that students seem to do better in their Leaving Cert than their pre, and maybe that there's a correlation between them. We're asked to draw a scatter graph to illustrate this relationship between the pre results and the Leaving Cert results, and to draw a line of best fit. Okay, so here we go. Here's our pre result. Here's our Leaving Cert result. There's our line of best fit. So what happens here? Or like, how do we come to this? Well, let me just have a look at these points here first. So say this point here is a student who hasn't performed that well. Student 8, 22% in their pre, 29% in their exam, the Leaving Cert exam. What else have we got? Say this person up here, well, that's actually student 11, performed the best. 85% in the pre, 91% in the exam. Okay, and the exam being the Leaving Cert. So what do we need to do here? We need to draw a line of best fit. You can draw it by eye, roughly speaking, as many points above the line as below the line. And, obviously some points might be on the line. So that is our line of best fit. And we've got 10 marks for the work we've done so far. Maybe the main part of the work was reading everything, but there we go. We got 10 marks. Now we're asked to find the equation of the line of best fit. Well, there's different ways of doing this. You can take any 2 points on the line, and as it happens, we actually have a few different points on the line. So you could actually take points from our table. So what does that look like? Around 55, 40. That might be student 1 there, that first point. And this is a score of 70 in the actual Leaving Cert. I'm looking for that. So that looks like it's student 3. So I could use y2 minus y1 over x2 minus x1 for those to find the slope. Or alternatively, you can put all the points into your calculator. So I'm doing this here for the Casio. Okay, the Casio, the natural display Casio. But there's a lot of different calculator types. There's the Casio Class Wiz out there now as well, and a lot of different Sharp models. So you have to make sure you can do this for your own calculator, and do not go into the Leaving Cert exam not being able to do this. You need to find R, which is, in this case, well, steps to find R. In this case, we will be finding R in a moment. That's going to be my correlation coefficient. But in this case, I follow a similar process at the start. I press mode, I press 2 for stat, I press 1 for a plus bx. I input my x values, which is going to be my pre-scores. I input my y values, which are going to be my Leaving Cert scores. I press AC, which is always, I find, a little bit of a scary moment where you're clearing the screen. But then you press Shift followed by the number 1. You press 5 for regression. You press 1 for A, and A is your 20.033. And remember, A is part of the equation of the line that you're getting here, and B is 0.89139, so on and so forth, and the B is here. So it's A plus BX, but remember, we write our equation as Y is equal to MX plus C. So in our case, it's Y equals BX plus A. So this B is going to be the first part. So having said all that, what is my answer going to be equal to? Well, my answer is going to be, this is my Y equals BX plus A, and the B was 0.891x plus my A, which was 20.033. Now, you might have a different answer to that because of the fact that you got your own slope, and you could have gotten the slope by getting a point from the actual line that you've drawn, and your line might be slightly different to my line, and that's okay. Once you have it done correctly, you're going to get your 5 marks, and the accuracy of your line of best fit will actually be shown clearly in this next part. Use the equation to predict the result as a percentage of the student in their Leaving Cert higher level maths exam if they obtained 50% in their pre-exam. So this is their pre-result, remember, is their X, that's their input, and their Y is their output, and that's their Leaving Cert exam. So our equation will suggest that if you got 50% in the pre, you're going to get 64.80% in the actual Leaving Cert. And remember, this is just an example. This isn't for you guys based on this pre or anything else. This is just an example. So Y is equal to 64.83%. Now, on the marking scheme, if you got anything, let me just check it to be sure. I think if you had any score between 60 and 70, you got full marks. Yes, that's correct. And any score between 54 and 74 got you partial credit, which was 3 marks from a total of 5. So that's how I suppose we can judge the accuracy of your line of best fit. If you got a score between 60 and 70, but when you put in 50, you got full marks. If you got a score between 54 and 74, you got 3 marks. Okay. Calculate the correlation coefficient correct to 4 decimal places. So this time, this is when we're calculating R. So we want to press mode, press 2 for stat, press 1 for A plus BX. You have to input the X and the Y values. You press AC again, press shift followed by the number 1. This time you're pressing 5 for regression again, but you press 3 for R, and here is your R. R is 0.89548, etc., etc. Okay, so what do we say? I want to correct to 4 decimal places. So here it is. Your correlation coefficient is 0.8955. There is a strong positive correlation between the two variables. This indicates that a student can expect to improve on his or her pre-result in the real examination. Okay, so what can we say? I suppose for all of these ones, we're going to see it again, I think, in a moment. You have to be able to do it. You have to be able to calculate the correlation coefficient if you're going to try this question. Of course, if you can't do it, if you cannot calculate the correlation coefficient, you really should be avoiding this question, because naturally you're not going to do well in it. Same with this one, calculate the mean and the standard deviation of the Leaving Cert results in maths for these 15 students correct to 1 decimal place. So now we're just looking at the Leaving Cert. The pre now isn't relevant in this case. We have our 2 answers here, but how do we get them? Again, on the Casio, to find X bar and then to find sigma X, we're going to do the same sort of thing. We start by pressing mode, we press 2 for stat, we press 1 for one variable, we input the X values, which are the Leaving Cert scores in this case, press AC again, press shift followed by the number 1, but this time we press 4 for variance. We press 2 to get X bar, the sample mean, that's 66.266, and so on and so forth. And then we press 3 for the standard deviation, and the standard deviations are 15.87. Okay, we want to correct a 1 decimal place here in the end. So we get the answer here of 66.3 and 15.9. And in those cases, again, they would be percentages. Now, what would I say? You would be able to calculate the mean probably by adding them all together and dividing by 15, but I don't think you'd be able to calculate the standard deviation without doing it on the formula. It would take a good bit of work without doing it on the calculator. So you have to know those if you're going into the exam and you're hoping to do questions on statistics. Okay, part B. So we've kind of moved on from what we've done already, but we're still in the same context. The teacher believes that the students in West Cork are not representative of the entire country. In fact, he believes that the math students in West Cork achieve a higher mean percentage than the national mean percentage score. Reading the report, he finds that the national mean percentage was 63% with a standard deviation of 17%. He uses the results from his own class as a sample to test his theory, conduct a hypothesis test at the 5% level of significance to examine the accuracy of the teacher's claim. Well, okay. We could do confidence intervals here, but what we're going to do instead is we're going to, of course, do our null hypothesis, H0, that the mean score of students in West Cork is 63, that mu will be 63. The alternate hypothesis is the mean score of students in West Cork is not 63, that mu is not equal to 63. The implication here, of course, is that the teacher thinks they're higher than 63, but that is not the alternate hypothesis. The alternate hypothesis is just that they're not 63. What do we know? We know the sample size is 15. We have a sample mean of 66.3. We got a population mean of 63, and we have a standard deviation in the population of 17. Okay, and that's important. It's standard deviation in the population. So it's Z is equal to X bar minus mu over sigma over root n. I put all these in. I get a value, a Z score of 0.75. That's far less than the Z score of 1.96 that I need to reject the null hypothesis. So in this case, I'm in the zone where I fail to reject the null hypothesis. The result is not significant. There is not enough evidence to reject the null hypothesis. Instead, we reject the claim of the teacher that the students at West Cork perform better. But of course, perhaps it was just that the sample was just too small at 15. Maybe if we increase the sample, we'd find out maybe he was right. That's the end of question 8. That was 15 marks. So some students would have performed very well in this question, and other people would have done very poorly because they would have got caught in not being able to calculate correlation coefficient, line of best fit, standard deviation, sample mean. So you got to be able to do those going into the exam.